Great, thank you. Great, Chris Fantine, Chief Technologist for the West Coast at Red Hat. I've been with Red Hat for about 13 years, and I work with customers up and down the coast, primarily Silicon Valley, who are adopting emerging technologies such as containers. And I'm going to talk about managing containerized microservices and databases with Kubernetes today. But first off, some of the industry drivers out there. This Andy Grove, back in the 90s, he talked about how only the paranoid survive. And it's not about security, but it's about strategic inflection points. It's moments in a company's lifetime when there's massive amounts of change going on around it. Maybe it's new technology, new competition, and the company has to decide, do they stay the course and continue as is, potentially becoming irrelevant, or pivot, change direction, and potentially thrive? And certainly, many companies out there today are having to face this decision right now. And it's because the disruptors are disrupting the incumbents, and they're leveraging software and automation. Take a look at the Tesla automobile factory. Certainly an example of automation. Right now, they're trying to ramp up their Model 3 production with software and automation. But after the car has left the factory, automation is playing a huge impact. For the first time, I can buy a car 6, 12, 18 months down the road. The car actually gets better because they have automated software updates being delivered to the vehicle, improving 0-60 time, battery efficiency, or the center console applications, perhaps a security fix. Right? And automation is at the center of the future of this industry. It's all about autonomous driving and eventually self-driving, and automation is a key part of delivering that. So there's a lot of pressure on existing companies, the incumbents. How do they stay relevant? Right? Within their organization is very static and planned mode of operation, focused on execution rather than innovation. When you look at the innovators, a very dynamic and policy-driven organization leveraged by automation. And so it's not just software and automation, though. The disruptors' key differentiators is that, one is they have a shortened feedback loop. They have their pulse on the market and their customers. They have real-time data, and they're able to respond and personalize as well. Take a look at Uber. They're able to adjust their pricing dynamically to attract more riders. Right? And then they're able to experiment, try things out in new cities. If it doesn't work, okay, move in a different direction. And they're able to deliver those capabilities rapidly in a matter of minutes or hours rather than weeks or months, because they've empowered their organization to make decisions quickly and eliminate the bottlenecks between siloed organizations. And they're able to deliver those capabilities into production from dev in a matter of minutes because they've automated, leveraging automated processes or automated tooling. And so there's a lot of pressure on IT to not continue to be viewed as a cost center, but an innovation center. And so that's why you're seeing a shift in how things are developed, how they're architected, and the underlying infrastructure. And so containerized microservices are a huge part of enabling the business to rapidly innovate, to be able to take an application from a developer's laptop and move it into production in a matter of minutes. And that's because they're containerizing these small, lightweight microservices with just the components they need, and they can build it once and then deploy anywhere, on any provider, any infrastructure. But what about containers at scale? Right? Kubernetes is becoming the de facto standard when it comes to managing containers at scale. And it's really building out this automated software factory that allows you to manage and orchestrate containers, improving the speed at which you can deliver, the resiliency of those services, the scalability, as well as it's being viewed as a security platform that standardizes the processes and the tooling across physical, virtual, private, or public cloud. And so today I'm going to talk about managing containerized microservices. We'll start with automation and then move through A/B testing. So if you haven't used Kubernetes yet, some of the key principles in how it automates your work is one is around orchestration. Right? It allows you to declaratively define your application. For instance, in this example, I have 2 web servers and a single app server. And Kubernetes will go ahead and deploy that in the available nodes, maybe it's physical, a cloud instance, or a virtual machine, and schedule that on an available resource, and then front end that with a service, right? That's a centralized IP that front ends and abstracts the underlying pods or containers, so if those change, it doesn't change the front end, right? And then you could actually bring in outside traffic with the ingress route as well. Now, over time, Kubernetes will automatically maintain the health of that cluster. It'll ensure that that declared state of 2 web servers and 1 app server is maintained. And so in this example, it's detected that there's an issue with the app server, and it went ahead and scheduled a replacement resource on the left there. And it automates your auto-scaling. So you don't get that page call at 2 a.m. in the morning because you're out of capacity, right? It'll allow you to set thresholds, and if they're overachieved, for example, on the CPU, it'll go ahead, in this case, deploy a second instance of the app server. Right? What are some best practices around container images, the core of the management system here? So first off, the basic flow of containers is that you build, ship, and run. You have a build file, a recipe for how to build the container image, right? It's a blueprint. You can go back in time, and you know exactly what was changed, how it was put together, and you can version control that. The container image can be shared, right, via a private or public registry, and therefore, you build it once in dev, you put it into the registry, and then it can be propagated to your dev, test, and production environments. And then the runtime, your container instance. It's instantiated from the image, and the Open Container Initiative has standardized the runtime and the file format so you can have portability across providers. Now, the container image, if you take a look, one of the key shifts is your developers are used to, if they're developing in Java, delivering a jar file, your application. Now, in the container world, they're actually delivering a container image. And what's inside that image? Right? You have the application that's been built from the jar, and you have your language runtimes, the immediate dependencies for that application to run, and the OS dependencies. Right? Think of this as a tarball, essentially, the image, with different layers, each layer having the difference in files. But who owns those individual layers? It seems like, wow, the developer's now taking on responsibility for these extra layers. But that's not the case. Right? With a container, you can define that image with a build file that's consistent across all the layers. No longer are you using different tools or syntaxes for these layers. So the sysadmin can own the base image of the OS, right? And then the middleware team can build upon that and provide the application runtime. And then the application developer can provide their layer built on top, just focusing on their business logic and their code. And one of the key principles around microservices and containers is to treat them as immutable. Right? What does that mean? That means extracting the data from the image, so extracting the configurations from the image, and storing those outside of the image. So the image should just have the runtimes in your application. The configurations should be pulled out. And Kubernetes provides a couple of objects that you can leverage. One is a config map. That allows you to import a key value pair. It could be a file, or it could be a value to store as an environment variable. And if you need to encrypt, such as a password, you could use the secrets. Now, the data, typically existing data is outside of the cluster, and you can access that via a remote data service. Or if you want to bring your data onto the cluster, you can leverage the persistent volumes. Now, let's take a closer look at the config map. So typically, I'll have an application, maybe it has some XML configuration, such as JBoss, and I'm going to store that in my source code repository, have it version controlled, but I can actually import that into the Kubernetes application definition in the config map. And then when I schedule that instance to be deployed in my cluster, it'll create a container instance, pull down the image, and then inject the config map value at instantiation, either as an environment variable, or if I've defined it as a file, it'll mount it and store it in the local file system. What about CI/CD pipeline? So the basic flow in a container environment is you have, of course, your continuous integration, you're taking the code and building that, but then you're taking the compiled application and putting it into an RPM, building out your container image, storing that in a registry, and then your continuous deployment is about taking that image from the registry and deploying it at scale in your dev test or production clusters. And Kubernetes enables a nice CI/CD pipeline really driven by the concept around network namespaces. It provides isolation in individual namespaces for you so that you can have, for example, dev, test, and production all as logically separate environments, but running on the same underlying physical infrastructure. So we see customers, they either use one cluster across the same infrastructure or they separate out production on its own cluster. And of course, this could be on physical, virtual, private, or public cloud. What about container image security, some best practices here? So here's an example of 4 different applications. You have C, Java, Node.js, Perl, PHP application, and the rectangles show you the components that are pulled in when you compile and build a container image for that application. In the second column, you have the Java. It pulled in the JRE, Bash, and glibc. Notice the triangle in the JRE, it's the number 66. Right? There's been at least 66 security notifications since the JRE was released, in this case for RHEL 7. So what you want to do from a security perspective, A, where am I getting these images from? But also, am I maintaining some sort of check to see if there are new security issues for my image on an ongoing basis? And so one of the first things that most users do is they implement a private registry in their enterprise. So they have a trusted source for their container images. It also acts as a repository, so down the road, 12, 18 months down the road, and I need to rebuild, I have all those components that I need. So make sure you're putting all the third-party components and not relying on a public registry for that. And then the second thing, if you're not using a registry that automatically scans those images as they're pushed, you also may want to implement a phase in your build pipeline. So this is a Jenkins build pipeline. And so I added a security phase, and it runs a scan every time I build a new container image. I could have it check for security vulnerabilities, or I could have it check to see if it applies with my security policy. There's upstream tools like OpenSCAP and a lot of third-party tools that provide that automation. And one of the other things around security is security issues aren't just about changing source code. Right? We see attacks against the build environment. So in a containerized environment, it's a good practice to make sure your container images are reproducible. How would you go about doing that? Well, you have your source code in the repository, but you also could leverage a version-controlled build image. Right? There's a container image with the build tools for your particular language, and you use that to actually compile and build your application and generate a container image on the right side here. And so that resulting output would just be your built application and the immediate dependencies that it needs. It doesn't have the build environment in it. So now I can go back in time and I know what version of the build image was used to build that particular container image. And I could do tagging or labels on my container image to track that. Right. One of the key things around microservices is to be able to experiment and try things out. And so there's a famous quote from Ronnie at Microsoft about how only 1/3 of the ideas improve the metrics they were designed to improve. And so how do I enable my developers to experiment and try out in a very controlled and automated way? And so I could leverage A/B testing with Canary deployments. Right? On the left side, I have my existing app. On the right, version B, I changed the recommendation engine. I want to see what the impact is to my business. And so in Kubernetes, I can deploy version A out into my cluster, front-ended by a service, and using my ingress routing to route 100% of the traffic. And I'm getting a 25% conversion rate. Right? Now I have developed this new version. and I want to see what is that conversion rate, experiment, and introduce it to live traffic. And so I've adjusted the ingress to route 25% to version B, and I see that it's been a positive impact on my application to a 30% conversion rate. And so I'm going to route all the traffic to version B. Now, if there was an issue and I saw the conversion rate decline, I could roll back and revert to my existing version. All right, that's Canary deployments in Kubernetes. Continuous feedback loop is a key part of this, right? You need to have a continuous feedback, so monitoring and logging was a key part to making these decisions. And as you move to a microservice-based environment, there are a couple things that are in addition in terms of monitoring. One is at the container level. And so there's some monitoring tools that we recommend to track that. And then also at the Kubernetes level for the cluster services, the pods, et cetera, popular to use Prometheus and Grafana. But also, as you shift from monolithic apps to microservices, you might want to consider you need some distributed tracing tools as well, such as Jaeger from Uber is a popular choice. And then Istio, we'll talk about in a bit. Next, I'm going to talk about blue-green all the way through what's next. So deployment strategies. Right? As you move to a container environment, your pipeline, you move from dev to production. Now you have this automated assembly line. You can push things in a matter of minutes. So the old process of patching production no longer applies, right? In a container environment, you always go back to development, and you build version N+1. Build it once, deploy everywhere. And so how do I go about deploying at scale? Instead of one physical server or 10 VMs, maybe I have 100 containers now. And so you need some automated processes. Today, your developers may have implemented this with custom scripts, but I can leverage an automated platform like Kubernetes to actually standardize this. And so we're going to go through 3 different types. One is recreate. So typically, you have version 1 out here in my cluster, front end by service. I'm testing out 1.2, and I want to deploy that. And so what I do is I bring down the existing cluster, and then I redeploy that new version. Right? That was a very simple and clean process. I really didn't have to interface with my application team. They didn't have to have backwards compatibility, no API versioning. The con is I had downtime. Right? So not all services can use this method. But if you can, it's great because it's very clean and simple. Also good for databases. Rolling updates. This is another approach, but it allows me to have 0 downtime. So here I have version 1 deployed out in my cluster, and I'm going to ensure that I don't bring something down before I deploy another, so I have the max unavailable and max surge set. And as I deploy version 1.2, you see it added an additional pod onto my cluster, and Kubernetes can have you perform a health check before it adds it in automatically into the load balancer. And so once it passes that check, I can then propagate it on a rolling basis across my cluster, 50% down to 100%. Right? And so this is good because it had 0 downtime. And I reduced my risk of an issue. I could always roll back at any time during this process. But I also need to be aware that I have 2 different versions in production at the same time. So from an application standpoint, I need to make sure that that's okay with my database. And I had a little bit of additional overhead as I deployed that initial pod. Next is blue-green deployments. Right? Here, I can leverage the ingress route, such as HA proxy, to route all my traffic to a blue production environment. Now I want to experiment and try out a new version. I can go ahead and put that in the green environment. I can run some testing. I can make sure the health check passes. And once it does, I can then change the ingress to route all the traffic to version 2. If there was an issue, I could roll back. So in this model, I never touched the blue environment. right? So it's low risk. I don't have to worry about reverting back. It's to be exactly how I left it, right? And also, I didn't have downtime. It was a simple switch, and I could do the rollback, right? But the thing to be aware of is now I have two environments, so additional resources. I also need to synchronize my data as well, if it's in the cluster. What about external services, though? If I have an existing application, typically the database, maybe it's in a mainframe, maybe it's a cloud service, outside of the cluster, right? And so, typical model is I have my development database service external on one IP, and on the right I have a production instance. Maybe these are in a cloud provider. So how do I interact with those? I don't want to hard code those IP addresses into my container image. I don't even want to put them in a config map because if I change that IP address, I may have to restart that service. And so an alternative approach is here I have my web app out in production. I want to be able to interface with those databases. Let's start out with the test first. And so what I can do is I can actually define a database service, but it doesn't point to any pods. Instead, it points to what's called an endpoint. And this is just an IP address that I've defined, and I've mapped the ports to my database service. So now I didn't have to touch anything in the container image to define that. And if I want to switch to my production database, I just change the endpoint. It's very simple and clean, no restarts. I could also do that for URIs as well and use CNAME to do a. Now, if I want to manage databases within the cluster, I need to have persistent volumes to store that data. And it's key to know kind of the persistence of the data depending on where you put it. So one option is you have data in the container itself. And that only lasts as long as that container lives. Right? If you restart it, it disappears. Right? And then data in the host volume. Right? If you're using a cloud instance and you restart it, it disappears. Or you can use a network volume, right? That allows you to access a persistent volume with your persistent volume claim and retain that data over time. And so when it comes to managing things like Postgres or MySQL database within a Kubernetes cluster, instead of using a traditional deployment or a replica set to deploy those, you would use what's called a stateful set. And the difference here is that it maintains a sticky network unique ID to that pod over time. Right? So in this case, I have a static host name, such as Mongo 0, Mongo 1, Mongo 2, and Kubernetes will automatically order those with the ordinal index, starting with 0, then 1, then 2. Right? And it'll do it incrementally in that manner. And if I roll back that and stop those services, it would actually remove them to 1, 0 in that order. It also allows you to have stable and persistent storage linked to the ordinal index name. And you have a front-end service, but it doesn't have an IP, because I want to have direct access from my client to the individual instances, in this case of the Mongo database. So let's go through that example. And so I'm going to go ahead and deploy a 2-instance replica stateful set of MongoDB. And I have a client out there as well. So the first instance is the leader, right? And that has read-write access to the database. So all requests can be fulfilled there. And from a data perspective, I've done a claim to the persistent volume to store my data. Now I would go ahead and instantiate that second instance and call it Mongo-1. Right? But this only has read access. Right? So I want my client to be able to direct traffic to either one. And because it has direct access, based on the Mongo 0 and the Mongo 1 name, I can do exactly that. And then Mongo can redirect writes from the read-only to the read-write instance if that was received at one of those requests. Also, I can easily scale my Mongo database installation to a third instance by updating the replicas. It'll also monitor the health of this cluster. So if there's an issue with Mongo 2, for instance, it'll go ahead and schedule a replacement. Notice it kept the host name consistent and also kept the persistent volume claim consistent as well. If I wanted to access it by URI, I could do that as well, and it'll use the CNAME redirection. And so the client can have a static and consistent name within the application to actually access that. What about database migrations? Folks ask, how do I manage databases? I see that I'm updating the application with rolling update or blue-green deployments, but what about my database? How do I integrate that? And so one of the things you can do is do a database migration. There are a lot of third-party tools out there, upstream open source. One is called Flyway. It allows you to create SQL migration scripts and version control your schema. Right? And you would store these SQL scripts into your source code repository, their version control and named appropriately. And then you would build an image with a Docker file, which would have this SQL database migration script in it, along with the tool, in this case Flyway. And you'll store that in your source code repository, and then you'll build the image. Right? So this would be a version-controlled image with the SQL migration script installed, mounted on a particular file system. And so I store that into the registry. And so what I want to do now is I want to be able to have, for instance, version 1 of the database aligned with version 1 of my app in prod, and then in test I'll have the next version, in dev and the third version, and I want to move those through the pipeline. And so what I can do is I can deploy, for instance, my PostgreSQL database as a stateful set out into one of my nodes, that's version 1. And then I can create a job. This is a special type of deployment within Kubernetes. Think of it as a cron job. And so this job is to be scheduled to launch the container image that I just created, right? And load a secret or config map with my connection information, so it'll attach that when it's launched, and then it'll run the migration script using JDBC, in this case, against the Postgres database. Right? And so you can see it being applied, and it updates it to version 2. Now, depending on your application, depending on your environment, you may need to, of course, bring down your database from live traffic before you do this, depending on what your scenario is. Okay. So what's next? Two of the technologies we want to take a look at in terms of managing microservices and databases. One is Istio. A lot of news around that. Basically, what it provides at a high level is the ability in a service mesh. You have all these microservices. The network is increasingly important. How do you manage traffic, right? So the individual microservices aren't bringing down your overall application. And so one of the things is it provides is more fine-grained control of your traffic. So in the example that we had of the rolling update, for example, I was updating 1 out of 6 instances at a time. What if you want more fine-grained control to route maybe just 1% or 2%? You can do that with Istio. Also, service resiliency. Right? When a service is not responding, you don't want to keep on trying, perhaps. Maybe you want to take a timeout and try in 5 minutes, right? And let it resolve itself. And then the earlier talk about chaos testing. It can enable chaos testing as well. And also observe, from a metrics perspective, how your microservices are performing, and be able to associate that with a distributed tracing tool to kind of see the traffic from service to service. And then, of course, security, enhancing security, managing the service-to-service keys, the rotation of those keys as well. So those are just some of the highlights and something to look out for. Also, CoreOS has developed this operators concept for Kubernetes. Right? Think of a public cloud service. Think of all the automation it brings to you. You don't have to worry about installing. You don't have to worry about HA, backups, upgrades, etc. But how do I have that same level of automation for my internally developed apps or a third-party app? Right? And that's what Operators is designed to do. is allow you to take your runbook and turn it into automation on top of Kubernetes in a native way. So now I can define that operator for my enterprise application or third party and automate backups, deployment, upgrades, even security checks to make sure there's no drift of my services on top of Kubernetes. And so operators, key thing to look out for as well. So I want to thank you for attending today's session. Here's my contact information. I'm on LinkedIn, my email address. Feel free to reach out. Also on Twitter. I'll be around the conference the rest of the day. If you have any questions, happy to answer those. Just walk up and say hello. Thanks.